A pleasant day, STEM learners. This is Sir Peter, your Precalculus teacher. Are you ready to learn again? For today's discussion, we will now proceed to our second topic. We are still on week 1, conics and circles. But for today, specifically, we will talk about the standard equations of a circle. At the end of the video lesson, you should be able to define a circle and determine the standard equation of a circle. So the question is, what is a circle? A circle may also be considered a special kind of ellipse. Just like in our previous discussion, in the discovery of Apollonius of Perga, the circle can be considered a special kind of ellipse. So therefore, we can also conclude that all circles are ellipses, but not all ellipses are circles. By definition, a circle as a conic is a set of all coplanar points such that the distance from a fixed point is constant. As I told you last time, the circle is considered a conic because it has a fixed point, a fixed line, just like this rotating line, and of course, a constant ratio, which is the distance from the point and the fixed line. The fixed point of the circle is called the center, and we all know that in geometry. And the constant distance from the center, this line, is called the radius of the circle. We all know for a fact that all the radii of the circle are congruent, and any point on the circle are equidistant from the center of the circle. Observe this figure, figure 1.7. The center has coordinates 3, 1. And observe a point P existing here. So the distance from point P to the center is actually the radius of circle C. So the measurement is indicated. The measurement is 5 units. In the same way, how do we interpret the measurements from point A to point C, or line segment AC? From point B to point C, or line segment BC? What do you think is the measurement? Correct. The answer is 5 units, because by definition, all the radii of the circle are congruent. The distance formula can also be performed here by subtracting the x values, 6 minus 3, that is 3, and then you square it, that is 9. Then 5 minus 1, that is 4, and then square it, so that is 16. And 9 plus 16 is 25. Getting the square root, that is applying the distance formula, the distance will be 5. So the derivation of the circle came from the distance formula. So here is the derivation. Suppose that we have a point C with coordinates HK and point P, which is any point on the circle, with coordinates XY. And the radius of the circle is represented by R, or it could be a distance between points P and C, or which is line segment BC. So that is in figure 1.8. Using that figure, we know that the radius in a given condition should always be greater than 0, because the circle will not exist if it is less than 0. So for the circle to exist, the radius must be greater than 0. And again, point P with coordinates XY should be on the circle That is, PC is equal to the radius r. Now, let us recall the distance formula. The distance formula states that d is equal to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. Do you remember this in your grade 10 mathematics? Transforming now the formula based from our figure 1.8, we will have line segment PC is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So this quantity. Next, our R, now, our line segment PC is now substituted by R, while the values x sub 2 was replaced by x, which is the first point of on the circle. And x sub 1 becomes the coordinate of the center, which is h. Y sub 2 is the coordinate of the point on the circle, which is y. And y sub 1 was replaced by k, which is the ordinate of the center. So we just use substitution. Next, we can transform the equation by squaring both sides of the equation. So we will have the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. And this, guys, is now what we call the standard equation of the circle, which is center at hk, meaning the center could be anywhere on the circle. So just follow this formula. Again, the derivation of the standard equation of the circle center at hk came from the distance formula. Any question? Now, the question is, what if the center is at the origin? So when we say at the origin, the center is at 0, 0. Based from this figure, we can say that the value of h is 0 and the value of k is 0. Substituting the values, then we will get the quantity x minus 0 squared plus the quantity y minus 0 squared is equal to r squared. And x minus 0 is x squared. Y minus 0 is y squared. So those are inside our quantities. So therefore, we will arrive on this final formula. So the standard equation of a circle center at 0, 0 will now be x squared plus y squared is equal to r squared. Now, let us have illustrative examples. Give the standard equation of the circle satisfying the given condition. First, the center is at the origin, radius is 4. So given this condition, we know that h is 0 and k is 0. So we simply use x squared plus y squared is equal to r squared. Following this format, what do you think is the standard equation of the circle? Correct. The answer is x squared plus y squared is equal to 16. This is how the graph looks like. So from the center, there is 4 units going to one of the points on the circle or one of the vertices. So the vertices are 4, 0, 0, 4, negative 4, 0, and 0, negative 4, respectively. So as you could see in the graph, the radius is labeled properly with a blue line. And the center is also indicated on the graph. Next. The center is at -1, 2, and the radius is the square root of 3. This time, we will follow the standard equation of a circle, the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. Using this standard equation, how do you think should we write the equation? Very good. The answer is the quantity of x plus 1 squared plus the quantity of y minus 2 squared is equal to 3. So how did we get this answer? Let me explain. So observe how the value of h and k changes sign in the formula. If your h is -1, in the formula, it becomes +1. If the k value is positive, in the formula, it is -2. So always remember that. And how did we get t on the right side of the equation? So we simply square. We get the square of the square root of 3. So we cancel. And what remains is 3. So this is now the final answer. How does the graph looks like? This is how the graph looks like. The center is indicated and the radius square root of 3 is also indicated. Question. Let us have another example. Given the figure on the right, give the standard equation of the circle. So our question is, circle A in figure 1.9. Observe circle A, which is the red circle here. First is to identify the center. Can you identify the center? So we will use capital letter to identify the center. So we have -2, -1. So what is the value of h? It is -2. What about k? Very good, it's -1. Now, we should determine the value of the radius. What is r in the figure? So from the center, you count either vertical or horizontal units in which you could easily count. For example, 1, 2, 3, 4. So obviously, it is exactly 4. So a circle with center at -2, -1 with radius 4 has a standard equation of what? Correct. The answer is the quantity x plus 2 squared plus the quantity y plus 1 squared is equal to 4 squared, which is 16. So I hope you understand this one because the center is at -2, -1, and the radius is 4. That's why we got 16 in the formula. Let's have another one. What about circle B in figure 1.9? Observe the blue circle on the right. Can you identify the center? The center is at 3, 2. Can you see that? Then from the center, let us count either the horizontal distance or a vertical distance going through any point on the circle. So we have 1, 2, 3. So obviously, there is exactly 3 units. So given a circle with center at P, -2, and radius R equals 3, what do you think is the standard equation of the circle? Very good. The correct answer is quantity x minus 3 squared plus the quantity y minus 2 squared is equal to 3 squared, or 9. So notice that the center is positive, positive. That's why in the formula, it's negative, negative. So we invert the signs. And do not forget to square the value of the radius, because in the formula, it should be r squared. Question. Now let's have the reverse of the skill. Identify the center and the radius of the circle given the following equations. First, we have x squared plus y squared is equal to 100. Can you give me the center and the radius? Correct. The answer is center is at the origin 0, 0, and r is equal to 10. So this is 10. Okay. So this is typographical. The answer is 10 only. I'm sorry for that. Let's proceed. So r is 10. Okay. Identify the center and the radius of the circle with the given equation. So we have 2x squared plus 2y squared is equal to 18. So this is quite a different problem. Hint. You may divide both sides of the equation by a certain number. Correct. So the answer is center is at 0, 0, r is equal to 3. So dividing both sides by 2 would give us an equation which is x squared plus y squared is equal to 9. And again, the center is at the origin and r is equal to 3. Identify the center and the radius of the circle given this equation. Can you identify the center? Look at HK. What about the radius? Very good. The answers are center is at 6, -5, and the radius is the square root of 49, which is 7. Notice how the formula changes into a point, which is the center of the circle. So for a -6 in a formula would mean a center at 6. And a +5 would mean -5 in the center. Question. What about this one? The quantity x plus 4 squared plus the quantity y plus 2 squared is equal to 8. Again, this is quite a different problem. So the correct answer is nice. You got it correctly again. The answer is center is at -4, -2. Notice how the sign changes value. I mean, the sign changes sign. And what about for the square root of 8? So the square root of 8 can be simplified as the square root of 4 times 2. And the square root of 4 is 2. And then simply write what is remaining on the radicand. So the simplified form of the radius is 2 the square root of 2. It is not the square root of 8. Okay? Always remember that the standard equation of the circle center at HK is this one. Okay? which is the quantity of x minus k squared plus the quantity y minus k squared is equal to r squared. In other references, we also refer to this formula as the center radius form. Again, this is the center radius form because it gives us the idea of the center and the radius of the circle. Likewise, the standard equation of a circle center at the origin or 0, 0 is x squared plus y squared is equal to r squared. So all you have to do is to square the radius, and since the center is at 0, 0, this is how you simply write the standard equation. So try to imagine and reflect a world without circles. So what will happen if we do not have circles? Observe the car with hexagonal tires, and observe this cup of coffee, the square cup. And I also can't imagine a square moon. This is how it would look like in the sky or in the night sky. What will happen if we live in a world full of circles? This is how your architectural design would look like. Isn't it fun? So here are the references used in my presentation. Did you learn something today? So on our next video lesson, we will talk about week number 2, the parabola. Specifically, we will discuss about the standard equation of a parabola vertex at 0, 0. So I hope you had fun in our discussion today. See you again. I am Sir Peter Paul Carrion, your virtual pre-calculus teacher.